Okay, so this video is on factoring and quadratics. There are three types of factoring methods we learned. Let me change the orientation. Okay, so the three types of factoring we learned are GCF. Okay, and this can happen with any number of terms. Difference of perfect squares, which only happens when there's a binomial. And then trinomials, which is with three terms. And for that, we can use reverse box method. Or reverse distribution. Okay, so for this first example, you're going to notice it's a little bit different. We didn't cover this in class, but I want to show you how what we did cover, you can use this. So even though there's four terms here, we can still use what we do for trinomials, which is the three terms. So reverse box method or reverse distribution. Instead of having to find the four terms for the box, you already just have them. And then if you were doing it the other way, you would just split it down the middle right away. Okay, so remember when you're doing the reverse, the numbers go on the inside. Okay, and I'm looking for what multiplies to get me x cubed and 4x squared. So that would give me an x squared. What multiplies to get me this? 4. And then this way would be x and 4 again. So my factoring would be x plus 4 and then x squared plus 4. Okay, same thing on this side. My GCF of x cubed and 4x squared is x squared. I divide them both by that, and I'm left with x plus 4. And then this side, my GCF is 4, and I'm left with x plus 4. When we make our final parentheses, I'm taking from these two numbers, so x squared plus 4. And then my second set of parentheses is what was in common, which is x plus 4. Okay, so the answer for both of these is this. Okay, example number 2, I have a trinomial again, but I want to make sure to check for GCF first, which I see. I see that I can have a GCF of 5. So I'm going to divide these all by 5, and I'm left with x squared minus 8x plus, I believe that's 16. Yep. Okay, and the GCF goes on the outside of the parentheses. And now I'm going to use trinomial for what's left over. So I'm going to create my factor sum table. When I find the factor, I'm going to multiply this so I get 16x squared. My sum is negative 8x, so I'm thinking what multiplies to get the 16x squared. So I think of 4x and 4x, but it needs to be a negative 8, so then both of these would have to be negative. And that works. So I'm going to change this to be x squared minus 4x plus 16. Oh. And then when I do reverse box method, I'm going to get x and x because that multiplies to get me x squared, and then negative 4 and negative 4. So my final answer, when I put those two in parentheses, is this, but I can't forget to bring down my GCF, which was 5. Okay, and lastly, I have a binomial and I check. Are these perfect squares? Yes. Is there a subtraction in the middle? Yes, so I can do DOPS. So that would get me p squared and p squared, positive 9 and negative 9. Remember to make your parentheses first before you say, can I do this again? And when I can do this again is only for the term with the negative. So my answer is still going to have p squared plus 9. This is just going to get brought down. The only thing I'm breaking up is the one with the negative, because I still have two perfect squares and a difference. So that's going to be p plus 3 and p minus 3. So this is going to be our final answer for this last one. Okay? And that's it for factoring. We'll continue tomorrow with quadratics.